be doing the procedure B, which reads B is a solution of sodium hydroxide containing 2 grams of the solute PDN cube. A is a solution of tetroxysulfate 6 acid. Feed a burette with A and titrate with 20 or 25 cn cube, depending on the volume of your pipette. Portion of B using methyl orange as an indicator. Record the volume of your pipette, tabulate your burette reading, and calculate the average volume of A used. So for we here, we are using 20 cn cube for as the volume of B. So from our result, we are asked to calculate the concentration of B in mole per dn cube, pH solution of A, amount of the traces of the 6 ions that react. So we are going to do it quick. All right, from our practicals, we have seen the final volume we have gotten for the first titration before the color change occurred is 24.4, the second 24.3, the third 24.2, and the last 24.3. We have seen the initial volumes to 0.000. So where the color change occurred, that's the titer we are taking. Titer volume in cn cube, we have the 24.4, 24.3, 24.4, and 24.3. So we'll take the average titer. The average titer means you are adding all the final result you obtained at where the color change occurred, and you're going to divide it by 4 because that you did it 4 times. So divided by 4, the average volume of acid used is 24.30. I think I should add 0 to it. 24.30. Now we have gotten to this point. We'll now go back to the question. What did the question say? So the question said we should calculate the concentration of B, that's the sodium hydroxide, the pH of A, that's the tetroxysulfate 6 acid, and the amount of the SO4 ions that reacted. So look at the calculations we have made. We have gotten the average acid. So the first step you do, you write out the parameters. The volume of tetroxysulfate 6 acid is 24.30 from our average. That's the average volume. And we have the volume of the base used is 20 cm cube. And then the concentration of the acid, we have not obtained it. The concentration of the base, we have not also obtained it. Now, from the question, if you look at it very clearly, we are told that B is a solution of sodium hydroxide containing 2 grams per dn cube of sodium hydroxide. Now, the 2 grams per dm cube is the mass concentration. Remember, mass concentration is given as gram per dn cube, while molar concentration is given as mole per dn cube. And remember the formula that says the molar concentration is mass concentration over molar mass. So your first step, you will write out a balance equation, the reaction between tetroxysulfate 6 acid and sodium hydroxide. And if you are balancing the equation, you see how balanced it is. So after balancing your equation, you see the tetroxysulfate 6 acid and sodium hydroxide, the ratio you are talking about the most now. Now look at it clearly from the previous page. The ratio 1 tetroxysulfate 6 acid to that of what? 2 sodium hydroxide. So that's the ratio. So the ratio is 1:2. Now for we to be able to calculate the concentration of B, we'll look at it now. You first of all get sodium hydroxide. Now we need to find the molar mass, because when we obtain the molar mass now, we'll be able to get the molar concentration. I didn't write molar concentration, but that is what has been asked in mole per dn cube, molar concentration. So the molar mass of sodium hydroxide, sodium, the mass is 23 plus 16 plus 1. So we'll look for the molar mass, and it's 23, that's for sodium, plus 16 grams, that's for oxygen, and 1 for hydrogen. So that's, you have 40 grams per mole as molar mass. And remember, your molar concentration of sodium hydroxide in mole per dn cube is given as the mass concentration of the sodium hydroxide, all about the molar mass. And from the question, the molar concentration has been given to be 2 grams per dm cube. So it's 2 all about 40. 40 is a molar mass of sodium hydroxide. And you'll be getting 0.05 mole per dm cube. Alright, so for you to be able to calculate the other parameters, you need to find the concentration, the molar concentration of the acid also. So you're going to use this formula of the concentration of acid times the volume of acid, or the concentration of base times the volume of base is equals to the number of moles of the base over the number of moles of the acid. So that is CAVA times NA is equals to CBVB times NB, where CA is the concentration of the acid, VA volume of acid, CB concentration of base, VB volume of base, and NA is the number of moles of acid, NB number of moles of the base. So from our question, or from our solving so far, the concentration of the acid has not been given, but we have been able to find the volume of the acid, the concentration of the base, the volume of the base, and remember the ratio that we obtained, right? 1:2. So inputting these values into the formula that was given. Now making the concentration of the acid the subject formula. Now you know how to do your subject formula, right? So you get the concentration of the acid is given by this CBVB and NB all over VA times NA, right? So you put all these values within, and when you calculate, you are getting the concentration of the acid as 0.082 mole per dm cube. Is that okay? Now, once we're able to obtain that, we can be able to find the pH of the solution. Now, we find the pH of the acid. I know the tetracyclic acid is a strong diprotic acid, right? That produces 2 hydrogen. Now look at the dissociation. There's 2 hydrogen ions, and then the SO4 ions, right? But you know that the concentration of the acid itself is 0.082, but since there are 2, so it will be 2 times 0.082, right? Which will give you 0.164. And you know that the pH of a solution is given as the negative log reading of the hydrogen ion concentration to the base 10, right? So now what you do, you go back, you take the hydrogen ion concentration, you find the log of it. So inputting it and getting the log, the pH of the acid will be given to you as 0.785. So if you approximate it, is 0.79. So that's the pH of the solution, that's the pH of the acid. Now, once you have done that, the next question said we should find the amount of the SO4 ions. So you know the amount of SO4 ions that we have from the equation now. You know, 1 mole of tetracyclic acid will give 1 mole of the sulfate ions, right? And 2 moles of hydrogen, which I showed you previously. If you dissociate tetracyclic ions, it will give you 2 hydrogen ions and 1 SO4 ions. Do you understand? So you know the most of the tetracyclic ion used now, the calculation will be the concentration of the tetracyclic acid times the volume of tetracyclic acid. That's what will give you the most. So, and the concentration is given, we obtained it to be 0.82 times the volume. I know the volume of the acid is actually 24.3 cm cube. So, but you know that for we to calculate it, or in that kind of conversion, you have to convert the cm cube to dm cube. So you are going to divide 24.3 cm cube by 1000 in order to get the dm cube. So the multiplication now is going to be 0.082. That's the concentration of the acid times 0.0243 dm cube. Are we together? So once you multiply it, this is what you're going to obtain, 0.0020 mole. And then if you are taking it like raised to power, you take it, how many zeros? This is 1, 2, 3, right? So it's going to be 2.0. I didn't put a 0.0, but you can add it if you wish. So that's 2 times 10 raised to the power of minus 3 moles of SO4 ions that was used. Are we together? So I think These are the three questions that were asked, and I'm sure you understand it. You can drop your comments, your questions, and where you have not understood. Remember the topic. Remember the topic is a calculation of pH or POH of solutions. Thank you.